The only reason I use -1 is because it's the closest to numbers.
Okay, so we're on this page here. We're still going to be doing what we did yesterday, which is solving these polynomial functions. So if you didn't grab a calculator, you might want one because we're still going to be using our table today. But we're going to maybe now start seeing ones where we have roots that show up more than once. And so we're going to like specifically state the multiplicity that roots have. And then we'll also start to see roots that are imaginary and how to deal with that. What's the matter? Okay, we're going to do this example together. So we've got f of x is equal to x to the fourth minus 6x to the third plus 22x squared minus 30x plus 13. First thing is just to kind of know how many roots there should be out there that you could possibly find. Remember, that comes from that leading term in the degree. So the leading term is x to the fourth. So your degree is 4, which means there's 4 roots possible that we could find. And that's what they have written down here on number 1. We want to find the possible rational roots using synthetic division. So what they're showing down below is they looked at this equation up here and they said their p was 13 and their q was a 1. And the factors of 13 are 1 and 13, and the factors of 1 are just 1. And so kind of like our bell ringer today, if we do 1 over 1, it's just 1, and 13 over 1 is just 13. So that's where they got those two numbers from, is our P's and Q's list. So now let's use a table. So I'm going to need you guys to do this part for me. Hit your table button on your calculators. I want you to type in this equation up here at the very top that we're starting with. Okay, I just circled it. Type that in, and I want you to be looking at 1, -1, 13, or -13. One of those should give us a 0 in our table, and we can use that.
Are the middle school kids here all day?
I think just the morning.
Sixth grade. Get them out of here.
Anyone got one yet? 1? Okay, so I'm going to bring down the 1, and then you grab your coefficients from the problem up above, which would be a 1, -6, 22, -30, and 13. Okay, we're going to do our synthetic division. And I'm getting a remainder of 0, which we should. We know that we should get a 0 for the remainder because we found that in the table. It went in perfectly. So then you write your depressed polynomial, which the first one started out as x to the 4th power. So this one's going to become x to the 3rd minus 5x squared plus 17x minus 13 equals 0. Now, if you could, at a point like this, because we're not done, we haven't found all the zeros yet. We found one of them. The one's a definite root for us, but we need to find the others. I would look at this and see that there's 4 terms. So I can't factor this like I would factor a quadratic, but factoring with 4 terms is when you group the first 2 and group the last 2. If I do that though, if I even just draw this in, guys, is it really going to be helpful? No, because, I mean, yes, you can take maybe an x squared out, but the parentheses aren't going to match, which just tells us we really can't factor this to do any good for us. So if you can't factor it, you have to do your P's and Q's again. But I want you guys to look at this equation. What's your P for this one? Ooh, not 1. 13, and Q is 1. So we have the exact same P's, Q's list that we did the first time. That won't always happen. You won't always get the same P's and Q's. But this one just happens to work that way out. So what I want you guys to do now is go to your calculator again, and I want you to type in this equation. And again, we're looking at 1, -1, 13, -13 to find a possible 0. Because we need to depress this polynomial even more so we can continue to solve it. So I'm going to draw an arrow to kind of just bring this up here, but I want you guys to find me a root. Does 1, -1, 13, or -13 work? 1 does. So 1 is showing up again as a root. Okay, we'll have to keep that in mind. It's showing up twice. So this is going to have multiplicity. Now let's grab our coefficients from this new equation, my depressed polynomial down here. So it would be 1. Yep. Yep. Good. And we do the same process again. We know we should get a remainder of 0. Which we do. And so now this can be depressed one more time, and it's going to say x squared now minus 4x plus 13. Can we factor that? Can you think of two numbers that multiply to 13 and add to -4? No. So what do we have to use if we can't factor? Quadratic formula. Okay, so that's down here on number 4, where it says find the remaining roots. It says the quadratic formula would be best here. So I'm going to take this, and we're going to use the quadratic formula on it. So what number goes in for B? 4. And it is a -4 up here. So if you write it like opposite of B, it would look like that, and it becomes a +4. Plus or minus -4 squared minus 4. What's my A? And C? And this is all over 2A, so 2 times 1. So this becomes 4 plus or minus. What happens underneath that square root sign? Oh, it gave you an error. It's interesting.
Error?
Can you not? Can you just type in the stuff underneath the square root without the square root for me, please? So don't do a square root sign. I know why it's giving you an error message, but you guys need to be able to see why. Should be -36. Which, why would your calculator give you an error there?
It's imaginary.
It's imaginary. You can't square root negative numbers. Okay, so when you're trying to simplify a square root like that, if you type it in with the square root sign and you get an error code from the calculator, that's telling you that it's trying to square root a negative and you can't. So instead, I would just focus on what does the numbers do. Now, if we were to, since we know about imaginary numbers, if we were to square root 36, what do we get? Plus or minus 6, but how do we take care of the negative? I. So 4 plus or minus 6i is all over a 2. The only thing I would say you should do here is simplify those whole numbers. What can you take out of all of them? A 2. So this is a 1 now. 6 becomes a 3. This 4 becomes a 2. And so this could be rewritten as just 2 plus or minus 3i. Okay, so down, last thing they want us to do is write out our solution set. So what are all of my roots? 1, and how many times did 1 show up? Twice. So after it, I'm going to put multiplicity of 2. I have to state that it showed up more than once. And then what were the other roots that we found? Good. How many total roots do I have listed there? 4. Because 1 showed up how many times? Twice. And then 2 plus 3i would be the third one. 2 minus 3i would be the fourth one. And if you go back to our original equation, way back up here at the top, the very first one I circled, remember how we talked about it should have at most 4 possible roots that we could find. We found them all. Okay, so let's do one more like this. This time, we got to do everything. Like they're not going to walk us through step by step. We're doing it all. So let's start with P's and Q's. What's your P for this equation? 24. And your Q? 1. All right. Anytime I see that the Q is 1, guys, you're always going to end up taking P divided by Q. So it's going to be the same numbers that you write out for your factors for the 24. because you're dividing all of those by 1. It's not going to impact anything. So I'm going to shortcut this just a little bit. What are factors of 24?
1, 2, 3, 4, 6, 8, 12, 24.
Good. So a bigger list than we had the last time. But again, all of those would be divided by a 1 because that's your only factors of the Q term. So that's why I'm kind of skipping that step. Now, if the Q had factors more than 1, like if it had a 1, a 2, a 3, whatever, then you probably are going to need to separate it out and write all of them. Okay, let's go to our table. Go ahead and type in this equation here and look for one that works. 2 works. Okay. I'm going to put 2 in the box here, and I'm going to write down my coefficients. Do you guys notice that it does skip the x to the third term? So we got to put in a 0. Make sure we still check for those things. If you miss that, it's going to impact everything you do from here on out. We know we should get a remainder of 0. So I'm going to go ahead and do this process here. Okay, so there's all my numbers with my synthetic division. How would I write my depressed polynomial? Okay, again, I would try to factor it if I can. I'm just imagining if I put parentheses in here, I don't think it's going to help me out again because from like the first 2 I can take out an x squared, but I'd be left with x plus 2. For the next one, if I take out a negative 2, I'm left with x plus 6. That's not going to match, so I can't factor it. So let's do p's and q's again. What are my p's for this equation? 12, okay, and my q? 1. So just like up above, I'm just going to write out the list because they all would be divided by 1. This should be a smaller list, though. I'm hearing 1, 2, 3, 4, 6, and 12. Okay, go to your calculator again. Two works again. Okay. This time your coefficients are 1, 2, negative 2, and a negative 12. Hopefully by now you guys are starting to feel a little bit more comfortable with your synthetic division process because we've done it a lot. How would you write your depressed polynomial here?
X squared.
Can we factor that? No. So we are at least at a quadratic now, which means we can definitely now go to the quadratic formula. So we can go to quadratic now. So I'm just going to draw an arrow. We're going to put that up here. So your b term is a 4, so it's going to look like negative 4. B squared would be 4 squared.
See, I just said all those answers.
What's your A?
1,
C
6.
all over 2 times 1. What do we get underneath our square root sign? Negative 8. And this is all over a 2. Now we can't square root negative 8, but we know now that that means there's going to be an I here in my answer. But you should be able to just square root an 8 and tell me what it would simplify to. 2 square root of 2. So how I'm going to write it is 2I square root of 2 all over 2. And what can I do? Can I simplify that at all? Take out the 2's. So let's write out our final answers here. Roots. are what? 2. What do I need to include about 2? Yep. And how do we write this simplified form of that quadratic? Very good. There's your final answer. How do we feel about that?
Easy.
Really, the only thing that's different is multiplicity we're stating now specifically, and i's are starting to show up. But not all will look like that. You know, the ones that we had yesterday, we found our roots. Some of them didn't have repeated roots. Some of them didn't have i's. Like you were actually able to work with the square roots. Okay. All right. The last thing we need to talk about in this section is if you're provided with the zeros for an equation, we can find the polynomial that those zeros came from. Again, we did this last year in Algebra 2 with quadratics. Like we would give you quadratic roots and you were able to find the quadratic equation they came from. And then we did do this with polynomials as well. We gave you the roots of the polynomial. We were then able to figure out what the answers would be. Or what the equation would be. Now, the only thing we're going to do here is also maybe have you evaluate the polynomial at a specific input so that we know what it would come out to be in like the y column. But we still might need to write out the equation first. So they're talking here in this example that they want us to find, it says find a third degree polynomial function with real coefficients that has -3 and I as zeros. And so that when I put a 1 into my polynomial equation, I'm going to get an 8 for my end result. So after I get my equation, I can check it with this to make sure that it satisfies that rule. That would just be another way for me to know I did it right. Okay? All right. To do this, because we have an I as a 0, I's come from what exactly? What happens in your problem in order for an I to come out? A negative square root. Now, if you square root something, how many answers do you get? 2. So they're only giving us one of them, which means we need to think about the other one as well. So because they're only giving us I have to add on -I for a third root here. Because they are also asking us to have a third degree polynomial, which means there should be 3 answers. So -3, I, and -I, which they're talking about down here, now also needs to be considered. What is happening? It's right there. Okay, so look at how they're writing this. It's being written for you guys right here. Oh, I had it highlighted and then it went away. Okay, so this is where you would start. That AN, guys, it's just talking about like the leading coefficient term. So right now we're not going to initially have anything in for that, but we just know that it would be representing a number in the future. I want you to more so think about what's in those parentheses. It says x plus 3, x minus 1, and x plus 1. What did they say our roots were? Up here? They have roots of -3 and an I. Why do you think down below, like it says x plus 3 and not x with a -3? It's always the opposite because when you guys set these up, it's always going to be x minus your root. When you set these up, it's always x minus your root. Okay? In this case, because I have a -3, when I plug it in, it changes to a plus sign. So that's why they wrote x plus 3 and then x minus the I and then x plus I. Because again, we had to add on -I to our list. And if I subtract a negative, it becomes positive. All right, now let's talk about how they got here. They had to FOIL these two pieces together that I'm kind of just putting those green marks around. So they had to multiply x minus 1 times x plus 1. So they did their foiling process first, outside, inside, last. Let's just do that so you can kind of see where they got this x squared plus 1. If I were to FOIL this quantity here, what would be your first term? x squared. Outside term, xi. I'm going to put the I first. And then the inside terms would be the same thing, but negative, which is good because something's going to happen here. And then last terms, negative I squared. Does anyone remember what an I squared represents?
Actually, isn't it just like the one? It's either 1 or 0.
-1.
-1. You were close. So -1 is always I squared. So anytime we see I squared, we can replace it with a -1. When you guys FOIL with these i's, a lot of times the conjugates are going to cause those middle terms to cancel. So this ix and negative ix, those are gone. I'm just going to cross those out. And then that negative I squared, if you put in a -1 here, it becomes +1. That's where they got this quantity from. X squared plus the 1. Now we got to multiply again. So this time what we're multiplying down below is we're taking this x plus 3 times the x squared plus 1. So you're foiling that again. So if you do your outside terms, x times x would be x to the third, which is what they have here. Or sorry, those would be your first terms. Outside would be the x times the 1, which they wrote here. And I'll tell you why they went out of order. The inside terms would be 3x squared, which is this one. And then last would be your 3. The reason why they switched those inner terms is because we're putting it in descending order. So we want those exponents to go down one at a time. Okay, so now what we can do to finalize, like this is our equation here. So I'm just going to circle this one. Like your equation could just be written as x to the third plus 3x squared plus x plus 3. But then remember, they also wanted us to satisfy that when I put a 1 in for my x's, that I got 8 for an answer. So down below, they're showing you here what happens if I put 1s in for all those x's. Now, they already kind of did the math for us. So this looks like this an, and then it'd be 1 to the third plus 3 times 1 squared plus 1 plus 3. And that's how they get these numbers here. Because 1 to the third is 1, 3 times 1 squared is 3, plus a 1 plus a 3. And we did get 8 for an answer. So it satisfies everything that we wanted it to. We worked with our roots that they gave us to get to our equation. We were able to then figure out what that answer was going to be. And because we got just 8 equals 8 here, that leading coefficient would just be a 1. Okay, we're going to do another one. We're going to do this one still together. This is the last one. Because do you guys have any more after this problem? Okay, yes, I crossed off some stuff, but I didn't know if I had reflected that in my notes before or after I printed them. Okay, we're going to do this last one. This will be it for the notes here for this section. So we want to still write an equation. We're still working with a 3-degree polynomial. It has roots of 5 and 2 minus I. And we want to satisfy that when I plug in a 1, I get 9 for my output. Okay, we have to think about this though. If I have a root of 2 minus I need the opposite. I need the conjugate of that as well to be added on, which would be 2 plus I. This is going to be a little different than the last one because they had to complicate the i's. So we need to talk about how you're going to handle this. Because it's not going to be as it's not going to be as easy as the last one. Okay, so I'm just going to preface this problem with that. All right, so we're going to start out by taking x minus all of our roots. So you're going to do x minus 5. There is technically an a sub n in the front of this. I'm probably not going to write a sub n all the time. I'm just going to know it's always there. Remember, we're always doing x minus our roots. So 5 was the first one, so that's why it says x minus 5. Then the next one is going to look like this, x minus this 2 minus I. And I'm still going to keep that in parentheses for right now. And then the next one would be x minus the 2 plus I. Do you guys see where I'm getting that stuff from? These are those I roots that they gave me. This time, though, it's not just I and negative I. They added those 2's in there. But I'm still taking x minus those roots. Okay, let's talk about how we're going to handle this. You really can't combine any terms because you've got x's and numbers and i's. Like, so you can't simplify it to make it maybe easier to do your foiling process. You could still foil or like use distributive property to solve this. Something though that I showed my kids last year, if you didn't have me last year in Algebra 2, I don't know if Mrs. Westhoff shows this or not, but when I'm multiplying something that's got a lot of terms, I like to use the box method. Have any of you heard about the box method? Okay, if you had me last year, you should know what the box method looks like because we used it. I'm going to use the box method to help me multiply this because I think it helps keep things organized. It can get really messy really fast if we try to do a lot of arrows and such. So here's how the box method works. If you've never seen it before, this is what it looks like. I take the first term, like the x minus the 2 and the minus I piece. Now I am going to distribute this negative in to these terms so that I don't have all these parentheses. And I'm going to write those in its own column. So I'm going to put x. The negative would go to the 2, so now it's negative 2. And this negative would go to the negative I, so it becomes just an I. I'm going to write it like that, and I'm going to draw a line like that because I'm creating my box. You guys with me so far? Do you guys see why those signs changed?
Yes.
These people are saying yes. I'm assuming. Okay. On the other side, this same thing's going to happen. We're going to distribute this minus sign. And I'm going to write these across the top. X minus 2. And then the last one's going to be a negative I. And then you're going to draw in some more lines to create these little boxes here. Now, when you multiply using the box method, you take a term from the top and a term from the side, you multiply them together, and that's what goes on the interior box. So, for example, x times x would be x squared. So that goes in that first box. And then you can go across the top if you'd like. You can go down the left-hand side. It really makes no difference how you go and multiply these terms. You just have to make sure that you do all of them. But this allows you to pair up all the terms that we would need to do if we were using distributive. But I think this helps keep it a little more organized if you're maybe someone who gets lost in the distributive property with a lot of arrows. So let's just go across the top. What would be negative 2 times x? Negative 2x. And then the last one would be negative ix. Okay, let's go to the next row. What would this first one say? Next one, 4. Very good. Last row. It'd be negative I squared, which I squared is replaced with a negative 1. But since it's negative, this would become positive 1. So I'm just going to put 1 here. Okay, look in that box. Do you see other terms that will cancel each other off? Which ones? The ix terms, because you got a negative here and you got a positive here. So I'm just going to cross those off. What else can we cross off? 2i and the negative 2i. Okay, everything else I can't eliminate, but do you guys see any more i's? No, they should go away. Every time you do problems with i's like this and you're multiplying, the i's should eventually go away because they should start canceling each other out or being replaced with the negative 1. So let's talk about what we have left here. We have an x squared. That takes care of this term. Also, a nice thing is your like terms are diagonal from each other, usually in the box. So this would be what? What I just circled there. What does that become? Negative 4x. So those are gone. Now, can you put the 4 with the 1?
Yes.
And you get 5. Okay. What else, though, from my original problem do I need to bring down to put in front of that? The x minus 5. Okay, remember there's still that a sub n sitting there. Okay, now we're back to kind of just more of a normal like polynomial here. You can use the box method again if you'd like to when you multiply, or you can maybe go back to using distributive property if you're comfortable with that. But we do need to multiply these two things together. What would you guys like me to do? Do you want to see the box method again, or do you want me to distribute? Okay, so let's do x times everything. So that would become x to the third minus 4x squared plus 5x. If we take negative 5 times everything, it's going to say negative 5x squared plus 20x. I'm running out of room. Minus 25. I'm sorry, I ran out of room, so I got to write that underneath it. Okay, what can you guys put together? So x to the third is left alone. How many x squareds do we have? And if we put these together, what does it become? My x's, what do they become? 25x, and then minus 25. Okay, and then again, remember, this all still has that a sub n. We're almost done, I promise. The worst of it is over, okay? Now, what up here, what number are they wanting me to put in for all my x's? Not 9. They want it to equal 9. We need to put a 1 in. So if you put a 1 in for all the x's here, this would become 1 to the third, which is just 1, minus 9, plus 25, minus 25. What does that equal if you do the math? Negative 8. Is that what they wanted? No. What did they want it to equal? 9. So what you have to think about is they wanted it to look like this. 9, they wanted it to equal whatever a sub n times that negative 8 would be. So the a sub n is representing the leading coefficient, the term that's in front of our big equation that we wrote. If I wanted to get that term by itself, I'd have to divide by the negative 8. So I'm going to have a fraction here. So that leading term has to be 9 over 8, and there should be a negative sitting out front. So my final equation here looks like this. That negative 9 over 8, and then times that big piece that we had. X to the third minus 9x squared plus 25x minus 25. That is your final answer. If it comes out where it already equals that, then your coefficient, your leading term is just a 1. And you don't have to worry about finding the fraction. All right, we are done.